Hive data model, we know that database is mapped to a folder inside your /user/hive/warehouse, whatever is a name.db folder. Tables are mapped to the folders which is inside your databases. So Hive data in the order of granularity would be, first will be databases, inside that would be tables. Inside a table will be your different columns that you're having. Partitions allow you to break up the data into different tables. Okay, why? So that you can have faster access to a query whenever a where clause is accessed. Let me give you an example. So if you are having, let's say, 1,000 rows, and you have got a column called as a region, and the value of the region is going to be APJ, your North America, and your EMEA. And if you write a SQL query called as select star from the table name where my region is equal to single quotes APJ. If it is not going to be a partition table, does it have to look through all the 1,000 records, folks? Can you give me an yes or a no? If it is not a partition data, will it have to go through all the 1,000 records to analyze the value? Yes, no? Yes. There would be a full table scan that is required, right? Sham, Janardhan, Aditya, Abhishek, Suraj. It's a full table scan, right? Hassan, right? Sheikh. Hey, why not Sheikh? It has to have a full table scan. Why did you say no? Because it is non-partition data. Okay, got it. But now if you partition it based on this region column, you will have 3 separate values for the regions, and now you can easily have a faster access to the data wherever you're writing a where clause. So right now, if I simply say over here, let me go down, tell me this, guys. If I say select star from TXN records where, let me go back, where my state is equal to, let me look at some sample data. It's already here. Recent files, TXNS1 should be, where sample state is equal to Ohio. Just one sec. Where state is equal to Ohio, semicolon. See, it is generating a map reduce job, okay, with the where clause, because this is not partitioned. Once it's partitioned, do you think it would require a map reduce program? No, friends, because it will simply do a full table scan. So whenever it needs a full table scan, it does not need a map reduce program at all, friends. Okay, so that's something that we'll have to be very careful. So I have got a lot of data with Ohio, so let it go ahead. See, it took about 34 seconds to give me all the Ohio states for me. Okay, so now if I simply say select star from TXN records, and when I press enter, trust me, there will be no map reduce code. See, I will do a control C because I know that it is going to give me 10,000, 1 million records. So that is crazy. So that's the reason why I did a control C. So select star is simply going to be a file dump. It is not going to be a map reduce things. Aditya, okay, that's it. So this is what I wanted to bring to your notice, the advantage of partitioning. Hive was developed using Java. Then we have got something called as bucketing. Okay, bucketing is typically done when you want to break the data into buckets based on some column. Bucketing is always done for sampling. So let's say you want 10% of the data, so you would say whatever might be the size of it, you will say I want to break it into 10 buckets so that each bucket will represent 10% of the data. So that is what is the purpose of bucketing, folks. Okay, let's talk about more about partitions. So partitioning actually means dividing a table into smaller coarse grain parts based on the value of the partition column. An example here given is date. So this makes it faster to do queries on slices of data. And I gave an example of a column being region, which will have APJ North America and EMEA. So a query on a where clause would be very fast as compared to analyzing the whole data set. So that's the advantage of partitioning. So partition keys determine how the data is going to be stored in different tables. Please remember, partitioning is going to be physical. Okay, it's not like normalizing. No, normalization is wherein you will have separate number of columns in tables, whereas partitioning is horizontal partitioning. You will have the same number of columns, but then the value of the rows would be different based on the columns. So that's the difference between horizontal and vertical partitioning, Abhishek. So is partitioning like normalization is what Abhishek asked me? It is not. Okay. So each unique value of the partition key determines a partition of the table, and typically partitions are named after dates so that you can do your analysis for your logs in a convenient fashion. So Hassan was saying, so is this partitioning concept similar to block splitting in your HDFS? Yes, block splitting is based on size, whereas over here in partitioning, it's based on the value of a column. Exactly. Okay, but then don't think it like it will be split into multiple separate blocks. Here it would be more on the value of a column. Perfect. So now let's go ahead. So this is what is bucketing. So the reason I said bucketing and subpartitioning are different is bucket gives extra structure to the data that can be used for more efficient queries. When you join two tables that is bucketed on the same column is typically implemented as a map side join. So when we talk about joins in MapReduce, there are two types of joins. There is map side join and reduce side join. That's what we will be seeing it next Saturday. So bucketing by user ID means we can quickly evaluate a query by running it on a randomized sample of the total set of users. So bucketing is for data sampling. Okay, so how are buckets created? Buckets are created based on the hash function of some of the on some columns of the table. So how bucketing and partitioning are different is, yes, it is hashing concept. That's correct. It's very much to do with the hashing concept in Java. So let me give you an example to understand how the records are going to be different. So let's take an example. If I have got a table which has got 1000 rows and I partition it based on column A, and column A has 5 unique values. Tell me how many partitions would be there. I have got a table with 1000 rows, okay, and I am partitioning it based on the column A. Column A has got 5 unique values, so obviously there will be 5 partitions. Okay, Hassan also had, yeah, most of you have answered it correct. That's nice. So this is what Hassan had to say. So these bucket concepts is to analyze it on a small set of data. Exactly. So the partitions would be 5. Now on the same table, I am going to do bucketing it based on column B. And when I'm saying bucketing, I want to specify the number of buckets. So I would say 10 buckets. Okay, I'm bucketing it based on column B. And column B has got, let's say 30 unique values. Tell me how many buckets would be there. It would actually be only 10 buckets because I have said 10. So please note, in bucketing it has got bucketing on a column has nothing to do with the uniqueness of the value in that column. So this is what is a very important aspect that you'll have to identify when we talk about bucketing versus partitioning. I said 10 buckets, right? So it would of course be 10 buckets. It has got nothing to do with the unique values. So bucketing is something like hash map hash table in Java. It is, let me show you what is bucketing. So bucketing is actually the hash of the column, then mod the number of buckets. Okay, so what it does is which bucket a particular row has to go would be dependent upon the hash of the column mod the number of buckets. So that's how bucketing would be done. Fine. So now we understood what is sampling and bucketing.